thanks for having me, Brandon. I really, it's a pleasure to be here. So I'm looking forward to this discussion. So I guess a little bit about chemical concepts. I mean, what we do is we're really product assembly people. So whether it's manufacturers, engineers, anybody putting things together, they come to us when they need um, really solutions involving, our core products are adhesives, sealants, tapes, specialty fasteners. So if they're looking for process improvements or they're looking to, have some kind of better performance in some way or another, or having some kind of engineering challenge that they're trying to solve, they come to us and we try and, kind of use our expertise in those areas to put something together for them. So we're involved in a bunch of different industries. A lot of the collaboration that we do with you guys is in the cladding facade market. We're also involved in, people putting, like I said, anything together, whether it's a bus or, transportation, even in, kitchen countertops. It's a pretty wide gamut, anyone that's using adhesives or fasteners. So it's a fun thing. We get to, kind of do something different every day. It is a family business, to answer part two of your question. And I was kind of born into this. So I'm a third generation here. I'm the national sales manager. And the company was founded by my great uncle. And it's, we're coming up, next year is actually going to be the 60-year anniversary. So we're really excited about that. We are we're kind of a weird kind of company, and it's just the way things have evolved. But, we're both a distributor and a manufacturer. There's some items that we've kind of developed over the years, but I guess primarily we're a distributor. So the genesis of this product, we're the North American master distributor of a company out of Italy called Special Insert, and they've developed all these innovative fastening solutions, and they've got a really strong R&D department. They've got some really smart people that have come up with some really innovative types of fasteners, and we just saw them as really a great fit for us in terms of what we were doing with adhesives and sealants, and it's through them is really what we've kind of branched out into these specialty fasteners, because for a long time we kind of competed against fastening, kind of in a big conceptual sense. It's like, well, don't use a fastener, use an adhesive. But we found so many applications where people were looking for an adhesive in conjunction, a fastener in conjunction with an adhesive, or just looking to help the best way for people to put X together, so sometimes the right answer is a fastener. So they developed the Deform nut. It's a patented system. They'll probably yell at me for getting the exact year wrong. I believe the Deform nut's probably around 5 years old or something like that. I would put it in that neighborhood. We're using the kind of the term Deform nut in the contexts that we're talking about. So that's actually the product, to go way back, that's actually the product that kind of Special Insert was kind of founded on. It's a specialty type of rivet nut, and if you're familiar with rivet nuts, you can go ahead and Google them. I won't spend too much time dog-earing into that, but so I just kind of say that as shorthand, but really the Deform nut is the kind of rivet nut. Rivet nut technology has been around, for a long time. They're kind of neat fasteners that kind of act like a rivet but give you a female mechanical anchor. And what we're really talking about is the Deform nut TC/DM, which is the specific series. So Special Insert has sold standard, rivet nuts, standard Deform nuts for, probably 30 plus years. I know their company goes back 3 generations too. But the people came to the Special Insert engineers and they were looking for the problem they were trying to solve was anchoring into hollow core materials. So that could be, honeycomb sandwich panels, which is primarily what you and I have been working on. Could be other kinds of composite sandwich panels. But there's a lot of solutions that kind of existed for solid materials, if it's, sheet goods, sheet metals. But with these new kind of composites that have been out there, and I use the word new, I mean, they've been using these things in aerospace for 30 or 40 years, but it's still kind of, in these composites are always evolving. It's just been a challenge of how do you create a secure connection into a solid core, into a hollow core material. So that's what the problem the Deform nut solves. So it's a two-step fastener basically. So one component of it is a deform nut where you drill a hole into the panel. The deform nut is inserted using a rivet tool kind of machine. It crimps or deforms the backside. Once it's inserted, the backside of it is deformed around the skin of the panel, so that it's kind of crimped between the face of the rivet and the part that's just been deformed around it. So that gives you a secure connection to the face, but the face of the panel is not really the structural component of a honeycomb panel. If we're talking about honeycomb panels, actually the honeycomb core itself is really the structural component. So that gives you kind of a starting point. Then using a structural adhesive is injected into the hole, and then a secondary screw they call the grub screw is inserted while the adhesive is still wet. And when the whole thing is said and done, you have a adhesive connection to the back face, you have a rivet connection to the front face, and then that grub screw is potted into the whole center, so you're structurally bonded to the surrounding honeycomb cells. So you basically are connecting to all three components of the honeycomb panel, and once that structural adhesive cures, you've got a really, really strong connection. I mean, we're talking, you and I have seen on some of the projects we've worked with, we've had to do pull testing for some of the exterior building facades. They required pull testings on the systems, and I'm trying to remember off the top of my head some of the values, but I believe we were in the 1,000 or 2,000 pound. They're in like the 2,000 pound range in terms of definitely in terms of shear. I think in a similar range in terms of tensile. And when we were doing the shear pulls, I mean, we were shearing the bolts, off, which is certainly what we like to see. And your other part of your question was, how is it different? So I'm not aware of, I think it is a patented system. I'm not aware of anything exactly quite like it. There are anchors that just require, you basically just pot a female insert into the honeycomb. There's some competitive systems out there. There's a lot of challenges associated with that, where you have to be, very careful. You have to be careful how you position things. There's nothing kind of holding the female anchor kind of in place while the adhesive cures. So there's kind of a lot that can kind of go wrong in that scenario. And then you're really just relying on the adhesive only, where, a lot of people like the fact that this is kind of a combination mechanical and adhesive connection. And what happens is that even when the adhesive cures, a lot of engineers get scared about adhesives, which, having an adhesive background, I get a little sensitive to that, but because I know what these adhesives can do, but still, when that adhesive cures, you end up with like a mass of adhesive that's bigger than the hole that you drilled. So that's really mechanical too. Once that's a solid mass, it can't come out unless you pull the whole panel apart. So it is actually mechanical once it cures. So, and then the other types of systems that I've seen, it basically involve putting an anchor in place while you're manufacturing the panel. So you have your sheet metal, you put your honeycomb core on top, then you put an anchor in, and then you lay the skin on top with the adhesive and put it in your press. And so it's kind of baked into the panel. So that's a good solution. I mean, they work well, they're strong, they're inexpensive, but when we get on projects, they don't always have the luxury of knowing where the anchor points are going to be when the panel's manufactured. And we work with a lot of people that are that do basically secondary operations, where they're buying panels that are already manufactured and cutting them down and then gluing some kind of material to the face. So if they want to have a stone facade on a building with a honeycomb backer, or a porcelain facade with a honeycomb backer, or some other kind of material, it's usually not, I guess you would say, the OEM of the panel that's really involved in doing the work. So they don't have the opportunity to put in the anchors when the composite panel is manufactured. They only want to put in the anchors after their new decorative skin is laminated on. So that's kind of the landscape of what we're kind of competing against and how we're a little bit different. So to install the anchor itself, you need the anchors, and the anchors are two parts. Like I mentioned, there's the deform nut and then the grub screw. So when you buy a set, it comes like that. You'll need a drill bit of the right size. It's a 13 millimeter drill bit. and we usually recommend like what they call an end mill cutter. So it's instead of just like a regular drill bit, like what they call jobber bits, or that you would find at the hardware store, this kind of drills a flat bottomed hole, which is important so that you make sure you're clearing out all of the, you want to drill through the honeycomb, clear out the aluminum shavings that would be in the middle of the honeycomb, and then also you want to take off that layer of cured epoxy from the bottom of the reverse side of the panel, so that you're giving a nice clean surface for the adhesive to kind of grab onto. So it's important to have, it's like a 4-fluted end mill cutter is what they're called. We do sell those bits, and frankly, you can get them on Amazon and other places where you just, once we give you the specifications. So, but we do as a convenience sell the bits. Then you just need some kind of rivet tool. There's manual and pneumatic tools. If you're doing a small project, the manual tools work fine. They're relatively inexpensive. I think they're, $100 or less for one of those. We sell them. There's other kind of rivet tools available because, like I said earlier, rivet nut technology has kind of been around for a long time. So, we're not the exclusive source for that kind of machinery. So you have flexibility in terms of, getting the equipment. We're really not out here to own you in terms of all the equipment. We just want to, again, help you out with your projects. And then with the pneumatic tools, if you're really doing, a lot of the stuff that we're targeting is, facades of, relatively large commercial buildings where, there could be many hundreds or even thousands of individual panels, and each panel might have, 8 or 10 fasteners. So depending on the sizes of the panels, we could be talking tens of thousands of fasteners. So in those cases, the pneumatic machines definitely make sense. We've got a good video kind of demonstrating the pneumatic tool where you see it inserts the tool, crimps it, and then unthreads itself in like one pull of the trigger. So it's a huge time saver. Those tools are relatively expensive, but they're certainly worth it in terms of, man hours is always the biggest concern that everybody has. And just the last thing you need is adhesive. So we sell the adhesive that goes along with it. And then those come in, again, depending on the scale of the job. You might need a small cartridge of adhesive or big ones if you're doing really a lot of these. And then what we sell is a 2-part structural acrylic adhesive that fits in a little cartridge gun. Maybe you've seen these kinds of systems where it's a 2-part system. It's kind of like a double-barrel caulking gun kind of thing, if you can imagine that. And we sell the dispensers for that as well. So that's basically all you would need. And then you're going to connect that presumably to some kind of rail system like you guys at Monarch provide. And then you would just need a bolt to connect the two systems, and we could certainly help you source the bolts that meet your requirements for the thickness of the honeycomb that you're using, and that matches all your other technical requirements in terms of kind of metal you need. Do you want 316 stainless, all that? Yeah, it's a pretty cool technology, and it basically, most of these honeycomb panels have an aluminum core. And we say honeycomb, if you look at it, you see all these little kind of hexagonal cells of honeycomb of aluminum. So when you have a front skin and a back skin and that kind of honeycomb matrix of aluminum in the middle that has a lot of air in it, you end up with a very lightweight panel that's also very rigid. And so that combination of lightweight and rigidity really solves a lot of problems that engineers are looking for. And that's the reason these kinds of materials are used in aerospace, they're used in rail and in transportation. We sell deform nuts for those applications where they're putting, trying to attach chairs to a honeycomb floor of a train, and they want to figure out a way to attach the seating to that. What we're seeing now too is in terms of facades, you're kind of seeing my understanding, again, my background is adhesives and fasteners, and I've learned a lot about these industries from participating in it, but I want to pretend to be an expert in facades and all that. But a lot of my understanding is that a lot of these designs are kind of things that are going on in Europe, where you're seeing, a lot of, more of these ventilated kind of facade kind of designs coming over. There's a lot of environmental benefits to those. and people love the look, from an architectural design standpoint. People love the look of natural stone. It's a natural product. It's sustainable. Sustainability is another kind of trend that this touches on, where, in the US we have LEED points and all these kinds of things, where government programs that are incentivizing companies to build green. Green building is on the minds of a lot of architects anyway, even without the government. Private companies want to stake their claim out there that they're doing the right things for the environment, and rightly so. So if you could use a sustainable product, but there's a lot of technical challenges that come with natural stone, as beautiful it is and as good for the environment as it is compared to other building materials. So if you want to get a 3 centimeter thick piece of granite and put it 20 stories up on a building, you can imagine, or even 100 stories, or whatever it is, you could imagine the kinds of engineering challenges that poses. So what people with this is probably the biggest thing that we see driving that, is in the natural and artificial man-made stone kind of world. People want that look of natural stone, but they want the lightweight, they want ease of installation. So the end users want it, the engineers want it, the installers want it. It saves everybody a lot of time and money basically throughout the process, from install to while it's in use to engineering, etc. So it's more cost intensive in terms of the fabrication of it, rather than just cutting stone to size. Now you got to cut the stone to size, you got to cut the stone very thin, you got to laminate it to the honeycomb panel. So there's a bit more work on the back end, but it saves a lot of work from every stage from that point on. And those are the big driving factors: the need for lightweight, the environmental friendliness, and just a lot of the logistical challenges too. Those are kind of what we see driving everything. I don't know about misconceptions. I think that still in the awareness, obviously it's a very, very niche product. I mean, it caters to a very specific application. So if you've never done exactly this and you've never come across us before, it's also a European product that's relatively new to North America. So I think awareness is probably the biggest thing that we face, which is, we talk to people and they say, someone told me to call you, or I'm not sure what to do, I found this online, or, this is what we're trying to do, we don't know how to do it. And so it's really just explaining the entire system from the beginning to them. I think really once they come to us and we kind of walk them through what they have to do, I think we're probably able to manage most of the unknowns from the beginning. I guess it's just a matter of understanding the alternatives, how this compared to the alternatives, and just trying to figure out what's the best fit for you and what we're trying to do and what you're trying to do. But as I mentioned earlier, there's not really a lot of options. So if you want to do this, if you have a honeycomb panel, you want to anchor it, there's very few existing systems that are just kind of ready to go and have clear instructions and all that. So that's kind of what we try and bring to the table there. There's been some, it's exciting because it's fun to take something and kind of something new and kind of put it out into the marketplace, and there's a lot of challenges associated with that. But what we're fortunate to have is, the track record in Europe, and then we're just basically trying to, replicate that success in the US, and the US has its own kind of regulatory hurdles. So that's not our background. We're new to the newish to the facade industry. We've been in industrial markets for a long time, so having to navigate and learn all the players, and it's been definitely a learning experience. But in the US, from my understanding, is kind of a patchwork of in terms of regulatory and testing of what's required. There's not really one, like in Europe, they've done a good job, I guess, in terms of making things very simple from the liability standpoint, very simple from a market approach standpoint, where they have an ETA certification. Once it's certified, it's certified. And they, it costs very expensive to do the certified, but once a product is certified, the liability said, well, what, this product was tested. That liability isn't on the manufacturer anymore, where they use the tested product. They've done their due diligence, and that's basically a stamp of approval on there. There's not really an equivalent to that in my understanding of, there's like regional things. So if you're in Miami, they have the Miami-Dade NOAs, where they want to make sure it's hurricane resistant. You go to California, there's special kind of earthquake resistance things. There's a lot of local things. There's ASTM tests, but the tests aren't quite certifications. The liability is still on the engineer to basically put their signature on that and say, we approve that, we've done our due diligence, and they're kind of accepting that, and we're a very litigious society, so of course those things kind of flow outward from there, that liability to everybody and their brother involved. But all that being said, I mean, we've done ASTM tests, we've done tensile, we've done shear. There's been some mock-ups that have been done. There's been some projectile testing that's part of the Miami-Dade NOAs. That I'm still kind of waiting on a status of that, but I've seen some of the videos. Basically what they do is they have a 2x4 cannon and they shoot a 2x4 at a mock-up, and so that's always fun to see. There's always that, when you see those kinds of things and you get involved in that, there's the little kid in you that just loves to see things kind of getting blown up, I guess. But that's kind of cool to see. But yeah, we did, so far we've met every expectation in terms of what kind of testing we've thrown at it. And I'm sure there's going to be more stuff that people are going to throw at us, in the future. I'll give my 2 cents, and, the industry veterans who may or may not be watching this can just kind of snicker at me if they want, I guess. But yeah, I mean, that's kind of back to my earlier answer. We're definitely seeing more of a focus on these ventilated facades. We're seeing the green building kind of trend in terms of that being more important to companies, and that's kind of a push-pull thing. You see the regulations are pushing, and then the companies are kind of want to do more. They want to showcase their credentials in terms of how green they are, and their commitment to sustainability and all that. So I believe there's been some, I'm not an expert on this, but I believe there's been some legislation recently, I think in New York, that that really put a lot of people in the building industry kind of into a tailspin. This is what people are telling me, at least, in terms of the thermal ratings on these buildings. You got all these glass buildings, and they said they kind of put laid the gauntlet down, saying, and I'm not an expert, I know it's like R values and all that kind of stuff, some specific R value. They said that all buildings in New York City, all new construction must meet the standard. And so that's, from what I understand, going to really drive demand for alternative. You're not going to just see these everything's glass. You're going to see a little bit more diversity in terms of, the companies are going to have to do different things in order to kind of get that, because it's difficult to achieve that kind of thermal insulation with glass. Light goes in, it's a very, it's very susceptible for warming and cooling from the sun. You lose a lot of thermal energy. So having that air gap of a ventilated facade where you have that column of air in between, that really does a whole lot in terms of helping to better insulate. You basically turn a skyscraper to a giant thermos is kind of my understanding. So I think there's going to be continued, I think regulation's going to, keep driving things forward. I think companies are going to keep driving things forward. And I think design is going to keep driving things forward. There's great artists, there's great, a lot of these architects are doing really beautiful things. And I think people are always going to want, nice looking buildings. People, there's the competitiveness where, IBM and Apple and these big companies, they want to have the shiniest, fanciest looking building out there. And to a certain extent, I get that. And so there's going to be those pressures that are going to be pushing that. And so that's my take, I guess, as a somewhat outsider into the industry. We attended, there was a new trade association that they put together. I believe it's called RENA now. So that'll be a plug for those guys, if any of you people are watching. And we're trying to learn as much as we can. So we attended. We got on this email list. We were fortunate enough to get on this email list to be kind of on the ground floor of them putting this together. And so we sat in on that first meeting where they're discussing do we need a trade show for the ventilated facade industry, and that's where we kind of learned a lot of that context, that it's really kind of a young industry in the U.S. too. There's a lot of misconceptions out there. They have their own challenges in terms of building awareness of what is a ventilated facade. And I think even among people in the building trade, I don't think there's a great understanding of what ventilated facades are, what the benefits are. And I think there's still a lot more market share to be gained from that kind of technology.